Hi everyone, and today is the second part of the sixth video. I'm gonna call it the seventh one, but anyways, today we're gonna create a model, a baseline model that would predict a numerical value. It's called a regression baseline model, and then like the classification one which we were predicting class targets with. We're gonna today predict some various numbers, and we began by importing the same, almost the same libraries as we did before. We import pandas as PD, a new dataset for a new kind of a target value. We're gonna use train test split as we did before, and today we're gonna use another metric. It's called mean absolute error. Right now, I don't feel like you need to take yourself into metrics, because I'm gonna do that in the next module. I'm gonna spend some time on some linear regression and logistic regression algorithms and tell you about all of the important metrics that exist. But right now, just I want you to comprehend that mean absolute error is just the mean value of the differences between what our model predicts and what actual values are. And so the ideal value for this metric is 0, as you may understand. And we also import numpy as NP. Firstly, what we're gonna do, we're just gonna run this cell and see something that load equals, for example, load diabetes, like that. What are the keys? So I have data target, so data a lot of time. So let's load the data set. Let's say just DS, well, short for the data set. Load on data. No, not we're gonna say that it's pd.data frame. Load data, and the columns. Columns are feature names, as we do, right, like that. So we may see an error, but what's the columns, feature names, data, and the shape of best values doesn't match. Feature names, there is a mistake somewhere. Shape of best values, as indices may imply. Oh, I'm a dumbass. I'm sorry. Like that. Load feature names. Let's see whether everything worked correct. So it did. What we're also gonna do, we're gonna target value. It's just load target, like that, and we were gonna look at the target itself, just to see that those are numerical values that we're gonna predict, like that. So we're also gonna split testing data. So ds.train, ds.test target. I copy that. Target train target test equals train test split, this thing, ds, and then target test size equals 0.33, as we always do it. For example, let's say that random state equals like 9. So we're gonna separate data and its targets into training and testing data sets, and the training one is 2 times bigger than the testing one, because the testing one is only 33% of the initial data set. So it's like 6 to 6.6 and 33.3, as I may imply. So the training data set is 2 times bigger. Let's see that everything was correctly. It does. And let's dive in straight into creation our model class. Let's say dummy regressor. Alright, I wanna call it something like baseline regressor, like that. Let's say that we have fed x equals none, we're gonna pass self, x equals none, y equals none, and what we're gonna do, in this model, what I wanna do is that I wanna just give the mean value of everything. Like every time we just give the mean value of the y. So we're gonna state that self mean equals np dot mean from y, so like that, and return self, and predict, for example, self and x equals none, like that. And what we're gonna return np.fall, length of x, and another thing that self.mean. So here's our baseline model. It's very few lines and it's very easy. The only thing that I was struggling to understand on the first time, because I didn't know what that was, is the np.fall function. And obviously you want your dataset to return an array with the same length as the data that you pass into it. And since we have only one value, we just need to give as a prediction this dataset with the same length as the x value. But it's gonna be filled with the mean value because we only have this one value. So it's like this, np.fall. It doesn't compile. Name none, it's not defined, I'm sorry. If that happens, just to read your code manually. And let's check whether it works correctly, like br equals baseline regressor, no, I'm sorry, baseline regressor, like that, and br.fed gs.train. What's wrong? Oh, alright, they are the train and target train, like that. It worked, and we're gonna print accuracy, like mean absolute error, like that, from br.predict, for example, gs test and target test, like that. And at 64%, which is the easiest model, because we don't know whether it's bad or good, like you might understand that. And if we had a harder model, we would get frustrated because we don't know, is it great or is it bad. The only way that we can understand that is to compare to others, but if there are no others, how can we even compare that? So what you can do is that you can just create a baseline model and try to understand how it works. And then we're gonna implement a baseline model from scikit-learn, because we don't want to write the same lines of code every time from scikit. I'm sorry, scikit-learn.dummies, import dummy regressor, like that. And let's see that in another dr equals dummy regressor, like that. And then let's say dr.fed, let's see, everything from this line, and just change br to dr.fed. And we have initialized our model. As you may see, it's fitted, so everything's great. And let's just write the same thing, mean absolute error, and I'm sorry, strategy equals mean, like that, I think. And gr, so it's like the same thing. Let's say that we have nothing here, so we can try to, for example, median value. Is median value better? It's the same. Well, that's weird. So that's the same situation that we have encountered. I don't know. What's the mistake here? Quantile. Strategy, I have to specify the desired quantile in the range. Like that. Okay, we don't care about that. We want the mean value. Maybe sometime we will encounter this one. So like that's the whole video, and it's a bit long still. And I personally think that is the end of this model. Next video is gonna be maybe the beginning of the next module and the ending of the first one, because I want to give you the first algorithm that you may just run by yourself without understanding how it works, just to try to touch it and try to feel that it's not as complicated as it seems to be, and then we're gonna dive into algorithms by themselves, and we're gonna dive into math and understand what metrics are and which metric to use is the best. So thanks everyone for watching.